Alright everyone, welcome to Advent Code Day 22. We are 4 days left until the end. Yesterday wasn't too bad. Fingers crossed that continues on today, but let's see what we got. Nice. The monkeys take you on surprisingly easy, unsurprisingly out of the jungle. They're not even going roughly in the right direction according to your handheld device's groove positioning system. As you walk, the monkeys explain that the groove is positioned to protect. Groove is protected by a force field. To pass through the force field to enter a password. Doing so involves tracing a specific path on a strangely shaped board. At least that's what you're pretty sure that's what they do. Elves aren't exactly floating monkey. The monkeys give you notes that they took last time the password saw the password entered. The first half of the monkey's notes is a map of the board. This is comprised of a set of open tiles, which you can move, draw on that, and solid walls and tiles you cannot move or cannot enter. The second half description of the path you must follow consists of alternating numbers and letters. A number indicates the number of tiles to move in the direction you're facing. If you're running into a wall, you stop moving forward and continue with the next instruction. A letter indicates whether or not to turn left or right. Okay. Means go forward 10 tiles, turn right clockwise 90 degrees, then go forward 5 tiles. Begin the path of the leftmost tile. Initially you're facing to the right. If movement instruction would take you off the map, you wrap around the other side of the board. In other words, if you're next, if you're at A and facing to the right is marked B, you're at. Okay, tile in front of you is marked D. Gotcha. Is it possible for the next tile to be a wall? It is possible for the next tile to be a wall. This still counts as being a wall in front of you. Okay. To finish providing the password to this strange input device, you need to determine the numbers of your final row column and facing as your final. Okay, let's. Fun. What is with these puzzles and their fun? Okay. So, how do I want to do this? The question is, how do I want to parse this? That's the big questions. How do you parse this to make sense? How do you parse this to make sense? You know what? Let's do this. Let's leave input as is. Let's try and do it without actually parsing anything. Let's do string instructions input get input dot size -1. So this is our instructions. I guess go to the end here. Okay, so we want to read. Let's go and bring this up into a char array. This is going to be .to char array. So for int I equals 0, while I is less than instructions dot length I plus plus. So string. Okay, so what we're gonna do is Boolean. How do I want to do this? Okay, so if letter I is greater than or equal to 0 and letter Oh, wait, not letter, instruction, sorry. Char. So what we're gonna do is we're gonna go letter by letter. So if letter is greater than or equal to 0 and letter is less than or equal to 9, I think it's that. And we have a letter and letter. That means we want to simply do ands plus equals letter. It's fine. Else if, right, if it's that and not letter, else if, actually let's do this, char, or not char, boolean is num. This is gonna be easier. Num is num. So if it is a number and actually we should do num. If it is a number and we are on a number, append it. If it is a number and we are not on a number, that means we are done. That means this gets, or can we just do curtains? Is there just like a clear? Okay. I don't think this is the fast way to do it, but this is the cool way I can know how to do it at the moment. Curtains is that. And then curtains dot append letter. Then we need to do number equals false. Int integer %. So this is our steps, I guess. Append the letter because that's the next thing. In theory, this part will never run, but okay. If it is not a number and we are on not a number, in theory, this will never run, but you know, whatever. And then is not a number and number. Okay. Okay, so oh, sorry, that is what I wanted. Is number and that. Okay. I think we're good. Let's apply all this. So in theory, this means we append, and then down here, again, it's another done. This is now a string step. There's not parsing to a number. I guess you could have multiple in a row. I guess you could have multiple in a row. So I guess this will run. But either way, number is now true. Good. Okay. So now what we need to do. I don't care about what it's complaining about. So now we have the whole steps. So what do we start? We start at 0, 0, I'm guessing. The leftmost open tile of the top row of tiles. Okay, so int row equals 0, int column equals 0, while inputs, okay, let's do string L1 equals inputs get 0, while L1 dot char at column is a space, L1 dot column plus plus. All right, so this will advance it to where we need it to be. So now we have the right row and column. Facing, do I have a direction? I don't have a direction. Private enum direction. This might be helpful to have as being enum in the future because you might be able to do fancy stuff with this. So up, down, left, right. This might come in handy. And then direction is equal to direction, and we're facing what to start? You're facing to the right. Okay, so this actually is going to come in handy. So what I can do is I can do public direction this, and we can have a private int row change column change, and we can add this to here. Oh, that's not a public. This dot row change equals row change. This dot column change equals column change. It's gonna be both final. Whoop. And so we're gonna need a public. I guess I should make this a point. Point. Column. Right. Point mutable, I guess. We need a mutable point. We need a mutable point. Or you know what? Screw it. I'm not gonna do this. Pause equals new point. This is just yeah, this is terrible idea, but yeah, okay, that works. That works too. Not ideal, but that works too. So this is actually gonna be point change. Point change. So up is gonna go -1 to row, column's the same. Down, left is -1 +1. So then public point move, and it's going to take in a point P, and it's going to return new point P dot row plus change dot row, and then P dot column plus change dot column. Okay. Good. And then actually we can do move, and then we can do int dist to make life bit easier. Oh no, but we gotta go one by one, because if the next point we're going to is a wall, okay, yeah, never mind. Okay, so when we actually move, so here we go. So steps. So we do need a public or private point move. Actually, no, because this is different. So for int, let's call it j equals 0, while j is less than steps, j++. So we're gonna go through all our steps here, and we're gonna do point moved to is gonna equal to direction move, and this is gonna be position. And so what we need to do is now check if our move to position okay, char c is going to be equal to inputs get move to row char at move to dot column. This is why I'm not doing the inputting, because we're just going to use the input as is to figure out our movement here. So we're going to do a check here. So if C, first one's easy. If C is a this, we do nothing. We just continue. Else if C is a space, that means we need to wrap around. So what we're gonna do is we're gonna do we're gonna need public direction opposite. Switch this case up, return down, case down, return up, case left, return right, case right, return left. Okay, so now if we grab the opposite, direction up equals dir dot opposite. Whoops. So move in the opposite direction, and so what we're gonna be doing is do now. Opposite move to. So while C2 does not equal another space, keep going. Just keep going. And then when we finally do get to there, we have to move again in our next direction. That way we actually get back into the grid and we're good. And so now we can set position equal to that and we're good. Oh, this does need to be continue, because otherwise we need to do this. Right? Right? I guess. Dude, I'll sit down here. Does not equal that. Do position equals move 2, but in here, direction move 2. Okay. I think we're good. Sorry, no, this isn't move. Position equals move 2. This one we actually need to move it still. Okay, I think we're good here. This should correctly move us, and if we hit something, we're good. So, this is also solvable by just doing a for char c in step dot to char array. We now need a public. That's private. I don't know. Public direction rotate and then Boolean clockwise. So up clockwise is right, that's left. Clockwise for down is left, and that is right. Clockwise for left is up, and that is down. And then clockwise for right is down and up. Okay, and all we do here is we just do direction equals direction dot rotate, and this is C equals right, I'm guessing. Whoops. And I think that's all we need. So what happens now is after this runs, we should be at the end. The final password is a sum of 1,000 times the row, 4 times the column, and then the facing. Okay, that means I mean, technically I don't need this get private. I need this int value on here. Zero is right. 1 for down. 3 for left. And I'm gonna guess, or 3 for up. 2 for left. Okay, so what we do here is now we can just do is lap of 1,000 times the row plus 4 times the column plus the facing. Dir dot value. In theory, please work. Index -1. Oh. Gotcha. Okay, so I need to make this a method. Private position or point wrap. Okay, so we need direction going. Where's move to? Actually, we should see this. Move to, and then we need a list of string, our input, and then return. Okay, so this is going to be position equals wrap. Oh. We also need the original position. Because what we need to do here is we need to do a final check of if C2 equals this. Oh, I can just do this. If it is that, we need to return position. Otherwise, we can turn move to. Because if we get to the end and it's a wall, well, we can't move there, so return back position. Okay, that works. So wrap. What all do you need for wrap again? Direction, position, move to, and input. So I do this all right. Okay. What this means though is I do need another one here. So I need to do a check here if move to dot column is less than 0 or move to dot column is greater than input it 0. Actually, I can just do line 1, can't I? It's up here. Line 1 dot length, or the row is less than 0, or the row is greater than or equal to input dot size. No, we can just do size because the last line's all blank anyways, so it'll flip around anyways. It's not a huge deal. So if that is the case, we need to wrap it around, and that's it. That's the step. The step there is it's wrapped around. This will handle it. Continue. Try that again. 73. Oh. Okay, and I need this check down here then too. Because while C2 is not empty... Wait, how does that work? Oh, I guess if it wraps around and goes to the... Okay. While C2 is... not this. Whoa. L1 equals input get 0. Oh. Right, because it's checked here. Okay, so this actually doesn't go here. This needs to go elsewhere. This needs to go after here. If any of these are true, break out of here, because that means we have gotten to the end. $75. Equal. Still? Move to column is greater than or equal to the length. How? I thought equal should handle that. Range 73. Oh, it's not. Oh. Alright, so technically the row should go first. Okay, so I should do string. Well. Row. Okay. I see. I don't want to. Okay, we're just going to duplicate the logic because it's fine. Okay, so it's going to be input.get this. Okay. So technically that should be the check. Let's try it again. Do I still have the -1 on there? Please don't have the -1 on there. I get an answer. I'm going to put that in. It's not right. Wishful thinking. Okay, let's try the example input. Wishful thinking. 5028. Okay. Very wishful thinking. I can do enhance for loop. Let's just see what we get. Let's just see what this is doing. So, okay, 10 to 1, right? So that's working correct. 10, right? So this is working correctly. So it's going to first start moving 10. Okay, and so we start here. So we should be moving 3 times. It should move 3 times just fine. Okay, 1, 2. Oh, right. Okay, yeah, so it's gonna stop here. So after this finishes running, we should be at whatever column that is. Right, so we shouldn't move anymore. So what's our position? 0, 10, column 10. I guess so. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's right. Okay, so now we get right. So what are we facing? We're facing down now, which is correct. Okay, we're facing down. Good, good, good. 0, 10, 0, 10, 1, 10. Okay, so we're moving down. We should move down. Keep moving down. Now we're trying to move right. We're gonna move right. 511, 50. So this is working. Down. Six, 3, 7, 3. Yeah, can't move any further. So now we're going right. 7, 4, 7, 5, 7, 7, 7, 7. Four, 7, 5, 7. Wait, we end in 5, 7. Oh my goodness, I'm an off by 1 error. I did everything right, but I got an off by 1 error because I'm counting from 0. Wait, right? 1, 2, 3, 4, 5, 6. Oh my goodness, it's an off by 1 error. Are you kidding me? I'm gonna be so upset. 6, 0, 30. Wow, I got this all right, only to be off by 1. Wow. Incredible. Incredible. As you reach the force field, you think you hear some elves in the distance. Perhaps they've already arrived. You approach the strange input device, but it isn't quite what the monkeys drew in the notes. Instead, you've met with a large cube, each with 6 faces and a square. The monkey's map does have 6 50-50 regions on it. You are, if you're to be careful to follow the map, you should be able to shape it into a cube. An example above the 6 smaller but the wrapping rules are different. Now, if you were to walk off the board, instead you proceed around the cube. What? Bruh. So, we instead of wrapping, we go around the cube. Dude. The flippity flip flip flip, what? So there are 50-by-50 cubes. So our input has one, 2, 3, 4, 5, 6. How in the world does this fold over? How does this, like, how? Okay, we're gonna be, this is gonna be 2 different logic. My logic is, I can't. I need to think about this. Okay, I think I'm gonna do this, but I think I'm just gonna hard code some things because I don't even want to figure out how to not hard code it. So I'm gonna break this up. Private int let's do long part 1. Yeah, we're just gonna break this up into part 1, part 2. That way I can kind of reuse what I need and get rid of what I don't. List. Lap, part 1, input. Okay, so we're gonna take this. And for part 2, how this is gonna work is same thing applies, but now we get into this wrapping. And I think this wrapping is where we're gonna get interesting. So it's whenever we call wrap. Technically, we're just calling wrap 2. Is what this is really becoming. This is becoming a wrap 2. And so with wrap 2, we need to know our position and how it changes from one cube to the next. So same thing applies. Let's just do one at a time. So we move, we go in the opposite direction still. Oh, no, we don't go in the opposite direction. Sorry. When we wrap, I should do it. Just do it this way. When we wrap around, it's different. So move 2 is our new position. So what we need to do is we need to get the we need to get our cube, or our cube face. So say we're in this cube going to this one. So if this is our top, we go over here, this drops down. So it's all about when we go from one cube to the next, how it changes our direction and changes. So what we just need is a mapper. All we need is a mapping between the cube we are on and how it changes. So we need a way to private int get face for point P, and I equal, this is going to be our 50 points row divided by 50. I guess what R50 C50, sure. Okay. So going from the input, row 0 equals 0 and C50 equals 1, return face 1. Three, 6, and then return. We should never get -1, so we'll leave that there. 2, face 2 is to the right of that. 3 is 1, 1. 4 is 0. Oh, wait. 4 is 0, 2, 2, 1, and 0, 3. 2, 3, 4, 5, 6. And so then we're going to need a private int. We're actually going to need this is where it'd be nice to have tuples in Java. Private. This is where it'd be nice to have tuples. Public position or point public direction actually I can make this a record. Okay, so private holder change face. So we need this to change face. So if we're going, we're just going to go through all the combinations. This is like the only way I can think about it. So from equals 1 and 2 equals 2. So we can go from 1 to 2. 1 to 2 is easy because it doesn't change. 1 to 2 doesn't change. Point P return new holder. I also need direction. I don't know if we need the 2p. Well, it's actually 2p, so we don't need from p. Because it doesn't, we don't change, even though we change the face of the cube, we don't change where we're going in here because this all still works the same. And then we're going to need the next face, which is going to be from 1 to 3. Actually, these are all reversible, aren't they? 1 to 2 or from 2 to 1. These are all the same. These are all reversible. So from 1 to 3 or 3 to 1. This is also the same. It doesn't matter. That's still the same. Now we start getting into the hard things. So 1, 2, 3, so 4. 1 to 4. I think these are, I don't think this is the same though. But we need to do it this way. So if we're going from 1 to 4, how does this change? Alrighty, welcome to Arts and Crafts with Turkey. I actually went and created, you can't really see it, it's me on the camera. I created a 1-inch cube version of my puzzle input. So now I can actually take this and physically figure out how things touch it. So one of these just must be wrong somewhere. But it's 2:30. I need to stop for now. I'll come back to this tomorrow, and I mean, it's just debugging is a fun life. So I'm close, but a few of these are wrong somehow, somewhere. Fun. All right, it is the next day. I've been trying to figure this out for a little bit now, and I'm still not getting there. It runs now fine. Some of my math in the translation between faces just must not be right. Some of this must be off in some capacity. So unfortunately, that means I'm just gonna accept today being a 1 star for now. Because again, it's not long until day 23 starts. So I'm gonna call this one here. For now, I have 1 star. Just know that this is a solution. Obviously, the solution only works for my inputs. It is very hard coded, but this works, quotation marks. Well, it's not working right now, but if I get all the math correct, this works. I just need to get there. So, yeah, this is gonna be a fun one to go try and edit. But at any rate, that's all I got for day 22. I'm so close, but so far. But yeah, thanks for watching. I'll see you guys all for day 23 here soon. Peace out.